Now I'll show you some adjustments that can be made to the pendulum. This first one may be the only adjustment that you ever need to make, and that is the speed adjustment, which I'll zoom in here at the bottom of the pendulum. You can see down there, there's a walnut knob hanging down below the bottom shaft, and that's attached to a threaded rod that can be screwed up or down by turning this knob. So if you want the clock to run faster, for example, you would turn it to the right, which brings it up and is actually raising this shaft here. It's pushing that upward, and that will make the clock run faster. To run slower, then you turn it to the left, which allows this shaft to move downward. Now once you have the clock within, fairly close, so it's running maybe, within a minute or two per hour of being accurate, then it doesn't take much of a turn to make quite a bit of difference. You can just try a quarter turn and let it run for a while and see how that goes. If it's running too fast, for example, then try a bit of a turn to the left to slow it down. A quarter turn like that will, I don't know the exact number, but it will make quite a bit of difference as far as minutes per day that it will change the speed of the clock. Now the pendulum, of course, is affected by humidity changes, so the clock is, of course, mostly a moving sculpture that's not extremely accurate, but by tweaking that knob there, you can get it to run within a few minutes a day of being right on time. Now the other two adjustments I'll show you, the one here is for the balance. And I'll zoom in and get a little closer here. You can see that this little weight hanging from a thread on the right hand side is it's on a horizontal shaft there, and it's just tied around with a slip knot. So that can be moved to the right or the left in order to balance the pendulum. And the way you can tell if it's balanced is by watching the escapement action. Let's see if I can get to where, let's see. It's a little hard to view both of those levers at the same time. Let's see if I'm up a little higher, maybe you can see them. Now you can see this one releases here, and then this one releases over here. And if the pendulum swings so that they release at about an equal amount, you can see that after this releases, then the pendulum keeps swinging a little bit. That's called recoil. So it lifts that lever up. And then here, after this releases, you can see the recoil of that. It lifts the lever up further. So if they lift about an equal amount away from the escape wheel, then you know it's in balance. And that doesn't really become an issue unless it's so extremely out of balance that one of those levers won't even lift up enough to release at all. That's the only time you would need to have to worry about switching this weight out here. And so it's very likely that will never need to be adjusted, but it's just something to show you and mention just in case. So let's say if this doesn't swing far enough to release this lever at all, that of course will stop the clock. And if you notice that, then this weight here would have to be moved to the left just to allow the pendulum to swing further, so that will release. And then of course if it's the other lever that won't release, then this needs to be moved to the right so it swings down further this way, so the other one will release the wheel. But like I said, that's more of a just in case kind of thing, and it's on a smaller clock like this, it's almost never an issue. Sometimes with especially some of the larger, wider clock pendulums, just because of changing a little bit in the wood, shifting through the years, or an extreme change in humidity, it's possible that the balance can be thrown off somewhat. So I always make sure people know about that adjustment anyway. Now, the other one is more of a tilting, front to back tilting of the pendulum. Now this knob right here that has the, I'll zoom up real close, that's got the strings attached, the suspension string, I can turn this and you can see it's lowering or raising that pendulum shaft there that runs front to back. So if I turn this, bring it up or down, what that ends up doing is changing the bottom of the pendulum. You can make it go back or front. Now I just stopped it because I lowered the front of the pendulum so that this actually ran into the wheel. So this adjustment always needs to be left, so that it can be made if need be, so that this, first of all, doesn't hit the wheel, and then if it's out, if I lift this, bring this up too far, and so it pulls this lower part of the pendulum out too far. And I'll show you on the other side what could happen. You can see how that bottom, that point on the shaft comes really close to the weight when the weight is in a certain spot as it's coming down. So if I change this enough, it actually will hit the weight, like right there, and then stop the clock. So this is just a way of making sure that the pendulum can kind of thread the needle, so to speak. So it doesn't hit that wheel there, and it doesn't hit the weight out here. Now again, that's an adjustment that very likely you will never have to make. I'll have that adjusted, of course, when I send the clock, and most likely nothing is going to happen that would cause this knob here to be turned and throw it out of adjustment. But again, that's just another possible adjustment that it's good to know about, just in case it ever needs to be done.